this is Erin, and here is the museum building at Tech, and you can see our disc cone antenna on the parapet right there. So it's a three and a half story building, and yeah, there's our antenna. There are trees around, but these trees are actually shorter than the parapet. There's a flagpole, and the building is actually kind of cool. Has like kind of little mining motifs. It's like Art Deco style. That's the gold and silver. That's the Montana motto, I think. And then one other thing I want to show you is up here. There's a map of Montana, and I'll point out where Butte is on it. It's kind of cool. So Butte is right there, kind of in the southwest of Montana. We're all surrounded by mountains. Okay. Alright, here's our antenna on the parapet, and line goes over here down into the building. Alright, there we go. Hi, this is Erin, and I'm going to show you the spectrum monitoring station. So there's where that cable comes up from the parapet to the antenna. And I have a shelf over here with the equipment. So there is our surge protector. The green wire goes to the electrical box ground. And then we have an FM filter. There's a 10K ohm resistor to ground. We modified it to discharge the static electricity. Here's an FM, a high pass filter to block signals below 174 megahertz. They were saturating our equipment. This is an LNA, and it gives us about 20 dBs of gain. It needs a external power supply. Because it's also acting like a powered limiting device. We have a 10 dB attenuator on the back of it. It's not ideal, but it's okay. And here is the spectrum analyzer. So it's running right now. It's connected to our PC via an Ethernet cord. So we have a switch to go to Montana Tech's network and to connect to the device. Those are just our external hard drive for archiving. And I'll just briefly mention, when I go out into the field, I'll use this laptop in this LNA. This is a better LNA. It gives us like 30 dBs or so, and the P1 dB is lower, so the attenuator isn't necessary. And we'll have external batteries for all of these things, for the RTSA and for the LNA. Okay, I'm gonna show you, just give you a little idea of what kind of data we're collecting. So this is kind of the header for the data acquisition 24/7. It's running right now. I don't know if you can tell. Yeah, so see that cursor, that means it's running. This is just a screenshot of the GUI. So RBW is about 477 kilohertz. The sweep time is typical, I think, with the Python script that I just showed you, it's usually a little bit lower. I would say 54, 55 is the median sweep time. It does go a little bit longer sometimes, like 1% of the time, I guess. There's not very many. Some of these are testing, but so we upload to YouTube automatically, so those are kind of the little credentials you need. Pretty simple setup. I'll show you some videos that compress the data. So with this, we're holding 100% sweeps and then finding the max and the min. This right here we think is the tech network. This is Verizon, or the Verizon band at 700. I think this is AT&T. Here's the unlicensed. You can see the roaming, or the signal jumping, I guess frequency hopping thing. I think this is TV. That's probably TV too. And we got either some repeaters or paging services right here. This signal, I think, changes the most. Sometimes it can be as high as up here or not. But we're collecting from 174 megahertz to 1 gigahertz. Yeah, I already said the RBW is about 477 kilohertz, so we're targeting 5 megahertz channels. So that'll give you an idea. And then I'll say a little bit more about the data acquisition. So at the end of the day, I'm going to reset it. I'm saving 3 files. These are the timestamps. I take the difference between each timestamp in milliseconds. This is our header. And these are actually the power data. And then when I go in to archive it, I use the 7-zip utility and I zip them all together. So this is for a full day, so it's about 1.4 gigabytes per day. These are all kind of partial, but I've been doing it on and off for, let me look. I even have some from August. So a couple weeks. And we can do this indefinitely, as long as we have storage space and power. Okay,